This is number 9 from 4.5 in Calculus 2. So what we have is a y prime equals y plus 5x squared. The initial condition of y of 0 is 15. And one way that we want to view this is just looking at how we're shown other ways of doing this. Dy dx plus p of x y equals f of x. And if we can get into this format, then we can follow some other patterns here. So if we were to take this and subtract the y from both sides, we'd have y prime equals, not equals, y prime minus y equals 5x squared. And in that, following this pattern, the p of x must be a -1. So one approach to this would be, and by the way, the f of x is just the 5x squared. And so we're looking for a function mu of x such that that'd be e to the integral of p of x dx. So that's going to be e to the integral of -1 dx, which becomes e to the -x. And we'll be able to take that and rewrite this as mu of x y prime or dy dx plus p of x mu of x times the y equals mu of x times f of x. And the nice thing here is then the right side will condense down to essentially a ddx. Oh, I should fix that. Erase, please. Thank you. A ddx of this function that you'll see in just a moment come out, that we can easily integrate that part. So our mu of x is e to the -x times y prime. And the p of x is -1, so -1 mu of x is e to the -x times y. And that gives us our e to the -x f of x. And our f of x we know is 5x squared. So this part condenses down into just the mu of x times y. So e to the -x times y equals our 5x squared e to the -x. And if we integrate both sides, so it's the integral of 5x squared e to the -x dx. Excuse me. The left side, that just cancels out, and you get your e to the -x y equals, and then we're going to have to integrate this other part by parts. And so I was going to use, and I haven't really done this so much in any of the videos I've made. I want to show the DI method, and that's where you do the derivative of one term and the integration of the other. And the one you choose the derivative for, in this case it works because you have something that will go away if you keep taking the derivative. So we have our 5x squared. You take the derivative, you end up with a 10x. Take the derivative, you get a 10. Then take the derivative, you get a 0. The other term, we have our e to the -x. We integrate each time for these. So negative e to the -x. Integrate again, e to the -x. Integrate again, negative e to the -x. And we stop because this row has a 0. And we go plus, minus, plus, minus. And then we're looking at this pattern here, going down diagonally. So we have plus 5x squared times e to the -x. So that's going to give us negative 5x squared e to the -x. Again, this negative here is from this negative here. And then we have minus 10x times e to the -x. And then we have plus 10 times negative e to the -x, so minus 10 e to the -x. then plus some constant c. And again, we're solving for y, so on the left side we want to get the y by itself, so I can divide everything by e to the negative x. And let's keep on moving here. So we have y equals, and let me change colors. These cancel here, they cancel there. I should say they divide out technically. And we end up with a negative 5x squared minus 10x minus 10 plus c over e to the negative x. And we have an initial condition for this, and that said y of 0 was 15, I believe. Let me go back up. Y of 0 is 15. So we can say if y of 0 is 15, that's going to be negative 5 times 0 squared minus 10 times 0 minus 10 plus c over e to the 0, and that should be 15. So we end up with obviously 0 there, 0 there, and then we have negative 10 plus, that's just e to the 0 is 1 plus c equals 15. So we can add 10 to both sides. So c must be 25. So y equals negative 5x squared minus 10x minus 10 plus 25 over e to the negative x. Oh, I probably should have done this. Thought about it, but didn't write it this time. Minus 5x squared minus 10x minus 10 plus 25 e to the x. There we go. I hope that helps.